Hi, welcome back. So we are at the outline to discuss using UML to model a class diagram. Basically, the definition of UML can be sometimes more abstract and a little bit theoretical, but in this particular program, we didn't want to actually bring UML as a subject of discussion from abstract and theory, but in a more practical way. Just let me give you a quick definition of what do we mean with UML. Well, UML, it stands for Unified Modeling Language, which is actually kind of a standard notion. It's used actually to visualize this kind of objects and class that we were talking about. And it's used in so many different other cases as well, widely used around the field of software engineering. Now, for us, to model the class diagram, and we know now the class is just the blueprint of an object that we defined. There are three important outcome from this UML. Number one, it will go and visualize for us the structural data, which represent, in other words, the attributes of the objects. And then you have this behavioral information, which is going to represent all the methods or the actions of a specific class. And finally, of course, it's going to display the kind of interaction between them using certain shapes of arrows, which we're going to talk about them in a while. Just let me tell you from this image that you see here inside this box, it represents the actual outcome of using UML to model a class diagram. So imagine that we define for a certain problem an object called a car, and then we manage to actually define all the kind of attribute, which is the data, and also the behaviors or the actions and method that surround the meaning of car, and then we convert that into what's called a class. So now in programming, we're going to create a class called a car. Now from UML, which comes before start programming at the first place, we're going to plot that in this way. So first, there are three important areas when we use UML. Area number one, it represents the name of the class. Area number two will represent the attributes, which is the data. And area number three will represent the operations or the methods or the interactions. So in this particular case, we give the name as a car, and then we have three important attributes or characteristic of the car we define to do. We have something called make, model, and year. Then we decided to create three important methods which are relevant to the use of the car. Method called start, stop, and drive. So you could see after each one of these attributes, there is this column followed by a word. And what does that mean? Represent actually this attribute belong to which kind of a data type, because these are data, right? These are the attributes, these are the variables as we discussed earlier. So when I say make, the country that made it, the model or the year. Now when I tell you a year, it's most likely to be an integer, it's a number, or an age, it's a number. But when I say a model or a name, it's obvious it's going to be a text, or in other words, from programming language perspective, it's going to be a string. So I don't want you actually to stick exactly to have string and integer. It just belong to a specific programming language, but I just want you to know that the way when we draw the UML, we're trying to indicate, hey, listen, we're going to define something called make, and it's going to have a data type as a string or a text. So in the future, when we start programming or creating the database around it, you must know that this field is going to have a type of a text. Similarly, it happens with the methods down there. So you got a colon and then followed by a certain word. Now here, the difference between this and this method, it is a kind of a system. So there is a certain input here, process is going to take place, and finally you get the output that we actually trying to do. This kind of a representative of a system is actually what method or function can do. What is the return out of this function? Here it will return nothing. Similarly here it will return nothing. Now this word called void, it's most likely used in C programming languages, which represent the word of returning nothing. Just it executes something. Now the last thing is to look at this open brackets for the function, which represent the input that I was talking about. Some functions expect you to give it something to do the process, and then will return something, or it will just execute something. So if you look at this drive, it expects you to give it a certain kind of input. Last but not least, these plus and minus that we can see here for the methods or the attributes, it represents something related to the access to these attributes or operations. In other words, to say, are they public or are they private? So we will discuss this in a more practical way. But this is the way you can see UML. It gives me an opportunity to actually draft everything. So if I am an engineer and make the analysis and create the design, and then I draw with UML, if another engineer come after me to actually execute or program that, just looking at this graph, you will understand the whole text without needing to read anything. Now let's look at some of the relationship represented with these arrows, that each one of them will actually represent something. So we have something called composition. We will get to understand that with some practical example once we use it, which has this end of a closed diamond. Opposite to that, you have a relation called an aggregation between two classes, and the only difference that one is open, one is closed. And then you have this straight arrow with a directed association, and then you have association. So the only difference that one of them has a direction, the other one does not have a direction, but this association between two. And then you have this kind of dependency relationship, which represented with this dashboard kind of a line. The only difference here between both of them is the word of use. The other one doesn't have that word. Then you have these two representation of generalization and realization. Well, to be honest, some of these are too much exaggerated and maybe you will never use them. But some of them are really useful, and that's what I'm trying to bring here. Just to try to show some cases about these lines, let's look at the association, which represent with this straight line. Imagine you have two classes, one called library, one called books. So this is a source and this is a kind of target. Now we know that each library will contain multiple books, and each book also will belong to a specific library. So it depends on you look at the problem from this perspective or from this perspective, it doesn't really matter. That's why we use an association between these two classes. Direction doesn't really important. But in this case, for example, direction happens to be important. When you got like teacher, a class, and you have a course class. So in this case, we say the teacher class is associated with a course, a class in the university system. This association is very clearly represented with this directionality. So the teacher is associated to a class. So this is the meaning or the way we read. It's not we say course is associated to the teacher, because the same course might be taught by different teachers as well. So this direction represents the actual relation between this. And then you have this something called composition, which actually represent with this example. Very interesting. You have a class called contact book, and you have a contact. Now we know that very important that if the contact, it is inside the contact book. But what happens if the contact book is deleted? Imagine for some reason the whole contact book is deleted, then you can expect every contact that was associated to this contact book will be also deleted. That means this is dependent on this. And that is the meaning of composition, which is dependency. It's very obvious here in this example. And we represent that by this drawing to say, well, the contact is associated to a contact book with a composition relationship through this closed diamond. In the opposite, we have something called aggregation, which kind of opposite to that. So this represents kind of independency, but with association. Imagine you have a company that has so many employees, and I want you to imagine if the company for somehow ceased or stopped working, you don't expect the employee also to completely stop working. They will find another job. So we can represent this kind of relationship between the employee class and the company class with a kind of aggregation kind of relationship with open diamond. So this is the two differences. So let's look at this inheritance relationship, which represented in this kind of a pyramid things. So you have a general class called a bank account, and then you have other classes like you have a current account, saving account, and you create account. Each one of independent class, or we call subclass. Now bank account in general has its kind of attributes or characteristic, and then the current account has its own characteristic or attributes and has its own method. The same for saving and credit. But all of them actually have also common kind of attributes or behavior. Instead of repeating that in each one of them, so we create a public one and then we inherit it from them. This is the meaning of inheritance. So I want you to be very much familiar with this kind of a drawing because it will make sense once we do it. And the next one related to something called an interface. We're going to have a lot of examples to represent the meaning of interface as we go along the line. Our previous examples about employee and payment, we created these two particular classes or objects. One belong to the employee, one belong to the payment. So if I ask you if we want to actually model that using UML into a kind of a graph, what would look like? Try to think about it, but you should have something similar to that. So here you have an employee class that we defined, and these are the actual attribute we spoke about last time: the name, the gender, etc. And these are the outcome, and the colon define them. And these are the functions that I spoke about last time, and you can see they belong to employee. And then I created payment, a class that, remember, doesn't have any attribute, but it has only behaviors or methods called calculated payment and pay. And then I wanted to represent the relation between both of them. So I used the association arrow. I'm using something perhaps I didn't talk about in the previous slide, but it's self-explanatory. So the multiple payment can be associated to one employee. This is the representative one or more payment with this little asterisk here is associated or for particular employees. So this kind of a relationship, it's very obvious that the employee can have multiple payment, one maybe a salary, incentive, etc., etc. So this is all what you need to know about the using of UML. You should be familiar only with the kind of a drawing that I spoke about, and I emphasize this can be really, really useful if you are working in a kind of a professional kind of a project. All right, so we have reached to one of the most important lessons in this particular outline, and it's to talk about the four important terminology of encapsulation, inheritance, polymorphism, and composition. And that's exactly what we are going to be talking about next. I'll see you then.